Yes, the season 2 something something. Be jolly, whatever. Why should I worry about these things? Even there's more important things going on in the world, like, you know, the potential end of civilization as we know it, or, you know, the whole social, economic, political environment that we're currently in, or the fact that there's an asteroid about to smash into the Earth and destroy us all. Makes most things kind of seem unimportant, doesn't it? Yeah, so anyway, hello, how are you, beautiful people? What have I got for you today? Oh, I've got a few teardowns that I wanted to do, and I would actually like to thank, who's the company I was just researching? A wonderful company by the name of NWIC decided to ship me a Planet gigabit midspan PoE switch. Now, actually what I should do, bear with me one second. Okay, I'm back. Alright, so what is a midspan? What is a midspan PoE switch? Well, I'll tell you this. So what a midspan, let me just put my balls over here. Get all my balls off the desk here. Bye, Santa. You can sit right here with Mr. Goat, or Miss Goat and Mr. Raccoon. Put our alcohol over here, get rid of our mice. Yeah, look at this pretty Christmas scene I'm trying to make for you wonderful folks. Might not quite work. Yeah, away with you, beastie. So this is what we call a midspan PoE. What is this? Well, it's a PoE injector, basically. Isn't that cool? There's a dead fly in behind the LCD there. The magic has been destroyed. So the concept here, and this one's only 100 meg, by the way. Built like a tank, though, but only 100 meg. So you've got, these are your LAN ports, and these are your PoE out ports. So the concept here is that you can connect like an 8-port switch to this guy here, to these ports, and then you'll be able to manage these 8 ports here. So they're just pass-throughs. There's no switching functionality to a midspan PoE injector, okay? Oh, there's still some of my blood on it from last time. Cool. But so anyway, whatever you put in here will come out port 1 and nowhere else. That's typically how that works. Alright, so the thing that I'm about to show you is actually a gigabit version of this, but it's not... I think this one is this one 24 volts or 48? What is this one out? I can't even remember. I'm pretty sure this is a 24 volt as well. I'm pretty sure it is. But anyway, let's go over and take a look at this. Okay, so... this... is an overbloated, massively overbuilt piece of shite, honestly. I'm not a big fan of this. So, what this is made by Planet. Here we go. I actually asked Planet if they were willing to sponsor a video and send me a couple of PoE injectors, but they kindly declined sending me a PoE switch, because apparently they do actually have a Natonix replacement, but they won't tell me exactly which model it is, nor will they actually, you know, send me an offer. You know, unlike Tycon or YTech or the other companies that sent me product to test. But anyway, so this is an Airdo 2.3 AT 12-port injector. So this guy here is 48 volt. I believe it's, what is it, 0.75 watts out, or amps, sorry. So, let's take it apart now. Oh yeah, 120 volts. Wow, is that ever a waste of space? That's the midspan right there. That is the 12-port midspan. So you can see that we've got 3 bays here. So 1 to 4, 5 to 8, and 9 to 12. Those are the bays here for the PoE pass-through, essentially. So you put your LAN into these ports on the bottom, and your PoE and data comes out the top. That's how this guy works. So let's do some testing. So let me just get one of my multimeters out here. Here's one, and there we go. I actually got these wicked new connectors thanks to a friend of mine. He went and cleaned out a big company that closed up in town here, because all the industry is leaving our city. So why not? Alright, so let's switch this to voltage here. I think, what is this, set for DC? Yeah, it's set for DC. Alright, cool. So let's power it up and see what we can get out of her. Which power bar shall I use? This one will work. There you go, and we'll plug it in. Should also make sure that these screws are going to go poppity pop. So, do I see anything that's going to go shorty short? Doesn't look like it, but I'm going to shield my eyes as I turn it on. It is on. Now, I probably should be not an idiot and collect the screws from inside of this case here, although what's really funny is because of the flex on that, it's, I'm going to take them out. Here. Gosh darn magnetic theory. Alright, so that's powered up now, so let's just take a look at something. And by the way, there's something else which I noticed inside of the switch. Some switches. It's like Inception, but with switches. So, What's really cool about that is I'm pretty sure that these are for reverse PoE. So let's check this out. So first of all, how many volts have we got coming off the power supply? We got 52.2, so not quite 54 volts, although I might actually steal this power supply for my own purposes, to be honest, because it looks like it's fairly high current. How many watts is this thing? It's probably going to be 7 amps, so that's going to be pretty decent. So let's, first of all, just dial this up a little bit so it's at 54.4, because that's typically what you want for a 48 volt device. The reason why it's 52 is because that way it's meeting in the middle, kind of thing. Okay, there we go. So we're just going to tuck those guys in there all tidy like. And we'll just dial it up just a wee bit. See, we want 54.4. Can we do? Oh, it does 54.2 is where it tops out. Oh, come on, planet. There we go. Excuse me, my camera appears to want to overheat right now, so I gotta keep an eye on it. Alright, so let's check this. And here's another cool thing, by the way. So here is the actual injector board. It has some minor intelligence here, I'm assuming for monitoring. It looks like it may... No, it doesn't look like it's actually got any current monitoring ability whatsoever, actually. It might have an overall current monitoring ability, but I don't see any kind of, current shunts on the interfaces themselves. I do see these beautiful fuses here. These are thermal breakers. They trip and then will reboot themselves, so as soon as they cool down. It's kind of a neat little thermal expansion type thingy. But there's the serial board, a serial to Ethernet adapter right here. So they've actually made their own little serial interface board that actually allows you to telnet, I'm assuming it's either telnet or SSH into this thing, and then it'll give you serial access to this guy right here to do whatever to it. So let's see how many volts that thing takes. I'm assuming this is either 5 or 12 coming in, so let's see what my guess is. Oh, it's 12 on the dot. Cool, so that's the management board for this thing. Alright, so now let's just, now that we've checked all that, I want to look at a few things, actually. I want to, where is the, Ethernet cable? I want to see if I'm correct. There's 3 bays of ports here, 1, 2, 3, and then there's 3 switches. So I have a sneaking suspicion that that is specifically for the purposes of, let's see here, reverse polarity PoE. So I'm just going to plug into port 1 here. Oh, hold on a second, I just realized something, actually. If this is 802.3AT, these ports may not activate on their own. I may actually have to, shit. This is definitely far from passive. Let's just see if I can get any juice off of this regardless. So we're gonna take our blue, and we're gonna take our brown, and we're gonna short them together, and hope that it may be AT, but it might also have a all-on. I mean, I technically could throw a resistor on here and trigger it or something, but whatever. Alright, so let's see if we get any power off this. Oh, see that pulse? It's trying to activate, but there's no load. Okay, so let's see here. So yes, it looks like it's already set for reverse, because watch the meter there. You see right now how I've got my brown to positive and blue to negative? And when you see the voltage jump, it's a little pulse, it's actually jumping up to 1 volt positive on this. Now if I reverse this, let's try reversing all of them. You gonna catch fire now? I'm pretty sure that is reverse PoE, but either way, I digress. Let's continue the teardown. So this is a serial interface board going over to this guy. We've got a separate 12 volt power supply. Like, look at the wasted space and inefficient design to this. This is sad. I mean, like, realistically, you could have used a higher efficiency power supply and tucked it in here and actually built a board that actually had Ethernet management on it, or maybe just put a console port on it, let somebody use their own interface on it. But regardless, I mean, like, the amount of space usage here is extremely inefficient in my opinion. And I mean, like, I'm a nobody. I just simply build things and fix things for people. I mean, that's my primary purpose in life, is to help you guys build your networks and fix your shit when you blow it up, or when God decides that he's angry with you and... Or no, that's right, God's a woman. Sorry, God gets angry with you and she decides to strike your equipment down and blow it all to shit, so... that's what we're here for. So, first of all, let's take out this cool little serial interfacing board. Let's see what we got here, because I'm pretty sure I know what this is. This looks like an RS-232 to Ethernet adapter, with a little bit of trickery built into it. Let's see here. And it also has the ability to control one fan. This is auxiliary fan, and the other one is main fan. So what do we got here? So main fan is controlled by this board, and auxiliary is controlled by this one. So let's see what pins are in use on this. Alright, so we've got 1, 2, 3, and that looks like a heavy-duty power pin right there for the fan. Okay, so it looks like it's got some fan control across this as well. So it looks like RS-232 from here to here, and then also fan control is traveling through this as well. Now, if we reverse engineer some of this, it's gonna be kind of cool. Alright, so let's put this guy aside. That little 12-volt power supply looks like it might be some fun. Now let's take out this 48-volt power connector. Get out of there! There we go. And, let's see what we got here. I want to make sure that, the caps in that power supply are discharged, or I'm gonna be ended up going boom electrically. There we go. See what I did there? Ah, okay, so this is the LED bar right here. So we got some little baby diodes on here and some little LEDs, cool. So I'm just gonna unplug that and toss that aside. And how do I get this out? It looks like this header is actually, this cap stand is also holding this in, so let's get that out. Alright, this is what we really want to look at. So that's the whole shebang right there. If you look here, you got 4 positive leads, 4 negative leads. That's how this thing's bound together. In fact, I can dump 54 volts straight into these ports, or into this interface here, and power this thing up, although I'm assuming that I have to actually enable the ports on here. So theoretically, we could cut the whole back of this rack off, fold the steel in, and basically reduce it just down to these 2 boards with a full bridge rectifier and terminal block on the back of this, and this would immediately become a DC switch. All the same. Of course, you need a 12-volt buck converter on this thing to convert this guy down, right? It's just the way that it works, but pretty standard stuff. Let's take a look here. So, looks like these... I might have been wrong on these switches. So, first of all, it looks like the middle switch goes to the fan. Interesting. Are these to control the fan? So this first switch goes here, or the second switch goes here to the fan, and then this switch here goes down through here to the CPU, or the sock on this. Now what the hell does the third switch do? The third switch ties into the fan as well. That is bizarre. I wonder if that's to change the fan voltage. Huh. I like the vias on these, by the way. The actual board mount vias are gold-plated. We've got some decent-sized FETs on here as well for our switching. So we've got 6 FETs on the bottom. There's probably, yeah, okay, 6 more on top. So that's, well, there's, what, how many are in here? 12? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so, yep, that's 12. 6, 12. Alright, so that's each one of these for switching the ports on and off. Protection diode here, it looks like. And these are our auto reset thermal fuses. So these guys will, the way that they work is kind of like a breaker. So what will happen is when too much current flows through them, the bimetallic strip inside will actually pop apart, and it won't reseat until the temperature cools. That's technically how these guys work here. So that's your protection there. We've got 1, 2, 3, 4, 5, 6, and 6, 12. And then this looks like it's for the core. 1, 2, 3, 4, 5, 6. That's for the main board right here is what it looks like. Now what do we got here for a chip? I'm curious. It's got a little tiny piece of thermal mass on top of it. Okay, so what do we got? Who makes this chip? Who are you? You are a D69012. Let me look you up. Alright, I'm going to my computer for a second. D69012. What are you? Nope, nothing comes up for that. Let me check the other numbers on it, okay? Alright, so we got D69012. We've got, what's the second set of numbers on? 9 zeros. Oh, there's something else before the D. Oh, it's partially rubbed off. I wonder if it's on this. The paint might have come off on it. Let's see here. No, I can't see anything. Got enough light here. Yeah, D69012. Oh, is that E or FD in front of it? Hold on. Try E. Let me try F. No, nothing. So let me try the second set on this. Oh, XAC1350J. No, I'm not coming up with much on this chip. 900600668A3. 9006688A2. Is that it? Oh, here we go. Got something here. It's on AliExpress, so it's got to be the right one. No, what the hell is that thing? Chip. No, I'm not finding anything on that, but from the looks of things, this is just a little intelligence controller. This is basically just a little serial interfaced relay device of some sort. So this may have serial interfacing on it. Let's see what leaves this guy. 1, 2, 3, 4. So there's actually 4 pins from that connector that come over to the CPU. So that's being said, there may not actually be any intelligence to this. My RS-232 assumption on here may actually be absolutely wrong, and that actually may be clock signals to the chip from here. So this may actually just be an all-in-one controller, and then this guy here is just the board. So this may be a generic controller. Yeah, shut up. Thank you. It would have turned itself off anyway. Alright, so we got our RAM and our ND RAM here, our chip. And this actually looks like an Ethernet interface chip, but it's definitely more than that. It's from Realtek. RTL 8186. I'm pretty sure it's a 100 meg network interface chip. Hold on.
A few minutes later.
Okay, what do we got here? 8186. Wow, I'm batting 1,000 for finding shit right now, eh? Oh, there it is. HK inventory. Okay, which one is this? This is the V. Alright. Let's see the spec sheet on this. I have to click 5 links to get to this? Come on. This is very Chinese. And I don't mean that in a racially charged manner. I mean, this is like, might be a white label product. Oh, that's odd. So I'm not finding this exact chip, but you know what? I'm not going to spend all night doing that because realistically, you guys just want a quick teardown. So, you know what? This may actually, I don't know if this actually legitimately is entirely Planet. I'm not entirely sure. There's a chance, and I'm not saying that it is, but there's a chance that this thing actually could have been white labeled by Planet. Now, something else to note here, by the way. Where's a pokey thingy? I want a pokey. I'm going to use a soldering tip, okay? Just the tip. Alright, so if you look around here, look at all the flux on this. There's tons of dirty flux left on the board here. It's all around the chip, which would lead me to believe that this whole unit has been refurbed. It's either been warranty repaired, or repaired before it left the product line, or sent back because this chip popped. And so you can see that they've lifted the chip and replaced it, but they didn't bother cleaning up all the flux around that, which is typical for low-quality components. You'll see that they leave the boards fairly dirty when they do the repairs like this. So, ROHS, yeah, there's no lead, thanks. Okay, cool, whatever. But, yeah, there's not really that much to this thing. I don't know if I really want to put it back together because it's kind of worthless. I mean, I might put it back together for the sake of putting on a shelf as a display in my new studio space, which I'm building to do some videos for you guys, some more advanced videos. In fact, I'm expecting a massive Cisco chassis to show up at some point, and it'll be very, very cool to do a teardown and walk you through the programming aspects of it. So let's see what we got in this thing. Okay, so this is unplugged, right? Yeah, it's unplugged. Okay. So the power supply is looking pretty decent in this. How many screws are holding this thing in? So we got those guys. I feel like there is some thermal compound on this. Any more screws? There might be. Yep, there are. I think it's that one right there. Yep, there's one right there. And there may... Nope, that's the only one. Feels like there's one more in this corner. Right there. Where is it? It's like right there under the mean wells. So where is that? Oh, there it is. 6 amps max at 120 volts. Cool beans. I'm gonna get the calculator up for that one. Alright, so what do we got here? So let's take a look at this. This is the main driver power supply that runs to 48 volt. This actually looks like a decent piece of tech. This is actually a Meanwell power supply, by the way. It's a Meanwell USP 350R9. So this is 350 watts at 48 volts. If we do the math, Where's my calculator? Calculator. Where is my calculator? There's gonna be a lot of shit cut out of this video. I am so sorry, Yuya. But, you know, I gotta crank the videos out, guys. You want them, so I'm working hard to get them. I want to do some neat teardowns, though. Nope, I don't want my calculator. There we go. So, 350 divided by 48, because 48 is the nominal number. I'm not gonna actually do the specific. 350 divided by 48. So this is 7 amps. Nice. So this is a 7 amp, 48 volt Meanwell power supply. That is not going back into that, because I have uses for this thing. Oh, do I? I think I'm actually gonna put this in my rack in the other room and use it to power my, my new switch, because I'm actually going to be putting one of the Tycons in place to start testing and running, which, why do I even need to test the Tycon? Everybody knows that it's good quality product, but this is a decent Meanwell power supply. So this looks like kit, this whole thing. So what I'm seeing here, oh, you know what I just realized? I didn't have to take those screws out, because the screws themselves actually hold the Meanwell together. It's just the 2 screws on the bottom of the unit that actually held this in. I apologize for my sniffing and snuffling, by the way. No, I don't have that horrible virus, that pandemic thing that's going around. In fact, I got my flu shot, and I have developed cold-like symptoms because I've worked myself like a dog again and ran my system into the ground. Remember, folks, if you work too hard, you will compromise your immune system and get sick. And that is not bullshit. So if you think that's anecdotal, that is wrong. There's scientific evidence to support that, and it has happened. In fact, the one day, I worked a solid 20 hours, and the next day, I literally woke up with a cold sore on my face. And I was just like, wow, that is great. By the way, a little trick to getting rid of cold sores. If you use a little bit of hydrogen peroxide, and like really soak it into the cold sore as soon as it shows up, it'll go away within a day. I shit you not. You can argue all you want, but I'm telling you right now that actually works. Okay, so this is a USP350. That's a nice power supply, dude. Alright, where'd the other screws go? So we got 2 over here. We should have 2 over here. No, I'm not seeing the other 2. I know we took some screws out. Huh, that's it then. Okay, cool. Yay, a prize. I think I'm going to convert that thing over to 48 volts, like DC in, just for shits and giggles. I mean, it's useless and it'll be a waste of my personal time to actually do that, but I think it'd be a cool little video to show you guys, because literally as long as you feed 54.4 into this, actually, this concerns me that this guy here has already popped. I'm wondering if the reason why this tops out at 52 is maybe because this board can't actually handle. You might be stretching it at 52 to run this thing, depending on the voltage regulator on here, which, where is the voltage regulator? Because the DC comes in here, and there should be a voltage regulator from this. Oh shit, I figured it out. This board requires power from the smaller power supply to operate. This power supply here is only for the purpose of powering the PoE ports. Ah, that's why we've got all this. So that explains the traces here. I gotcha. So this comes into this switch here. This is the switch for right here for turning it on and off, but there should be a voltage regulator around here that knocks it down from 12 to 3.3 or 1.3 depending on what this chip requires. Unless, hold on. It's a cool teardown, by the way. I didn't expect to get in that depth. I have a feeling that, okay, so our power comes in here. This is what goes with, there's a VR right here. So this VR is probably, there's 2. So there's one over here, one over here. So I'm assuming that's what's happening is actually the down conversion is happening in here on this part of the power board, or the part of the board. Here's our power circuitry here and here. And then it's actually sending the juice needed to operate the intelligence on this board over this interface. So that would lead me to the conclusion that I'm probably 100% correct, that this is a internal clock. It's GPIO between these two, with deep power actually coming from here to drive the intelligence on this board, and this is strictly, power from this is only feeding the PoE ports on this. That is cool. So to make this thing work, let me grab a pad of paper. Let's see here. Pad of paper. I have paper. I know I do. Get your number 2, folks. Here we go. This is exciting. Alright, so here's our switch. Okay, here's our first board here, and then our little power board. So this is 12 volts to here, and then we've got our switch board here. Okay, and then we've got our big, chonky mean well. Okay, and here's our AC, our means. Okay, that comes in here, and yeah, so then this guy comes over to this guy here like so, and then this guy comes over to here. So this is the GPIO, or the clock, and low voltage for the logic. Okay, so that feeds into here. So this is whatever voltage in here. So theoretically, what we can actually do is take this little bastard here, and here's our switch again. Oh no, I'm drawing it again. Oh my god, I am so sorry. No, I'm not. You're learning, right? This is the purposes of what I do. So this is 12 volts in, and this is 48 volts in. It was actually 52.2. Oh, now she's gonna start right now, right? Oh, watch this. Hopefully that startles her. Okay, so now what I can actually do is I can put a set of banana plugs on here, right? And then this will come in here. Okay, let me try that explanation again. Alright, so we've got our 12 volts here, and we've got 48 volts needs to go here, right? 52.2. I'm pretty sure we'll test this to see if it'll take 54.4. Okay, because this is actually, the logic here is coming from over here, which means that this chip here doesn't get power from here. So what we would actually do is we would bring this in, and then we would have our full bridge rectifier here. How do I draw that now? We've got like this, and then plus and minus. So shit, we'd have like this, our two diodes. Okay. Oh, I hate drawing these. Because you know what, I always get diodes mixed up in the direction that they're supposed to go, right? Okay, so this is positive here, and we're gonna call this one negative, okay? Just because I screwed up the way that I drew it. Okay, and then this one goes like this, and like so, away from it. So there's our full bridge rectifier. So this will actually, in fact, come in like so, boop, 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 like so, to there. This goes into here. This does our polarity correction to make sure that everything's happy. And then we would actually, we could put a fuse on this if we really wanted to. We might. We can just go like this, fuse, right? Like so. And what we would do is bring the power over here to this one, and then back down to our unit here, and then our negative would also go like so down to here. So we'd have our positive negative 48 going straight to here, but then we would have a small DC to DC 48 to 12. So this guy would come in like so. So we would actually take our power off of here. So we'd have our positive go in and our negative like so, and then we would have our positive and negative go down to here for our 12 volts. And then this has now become a DC switch. We've got our DC 54 in, and this is polarity insensitive right here. You can put positive and negative on either one, and it'll go in, and this full bridge rectifier, FBR, will correct the current, and then you'll have your 48 continue down to here, and then you will have your, let's see here, down convert, your buck convert from 48 to 12, and then down into this module, which will also convert down to 1.3, 3.3, and maybe 5. Probably 1.3 and 3.3 to control the logic on this chip. Neat, eh? It's, yeah, it's really not that complicated. Okay, I'm not saying that to be facetious. I mean, like, seriously, the DC aspect of this is really simple, and when you actually look at the board design here, look, it's pretty simple. Power supply, that takes 120 volts in and converts it to 48 volts DC. This is the actual Hpoe midspan. These ports are literally stacked. In, out, in, out, in, out, right? And all it is power feeding in. These FETs turn it on and off, feeding these ports here. And then you've got your logic, your data controller. Where did I put it? Here it is right here. And this guy literally powers the logic here. So this is, which one would you consider the daughter board, by the way? This one or this one? Think about that. Which one's the priority board? Technically, I think this would be the motherboard and this would be the daughter board, even though this is girthier. So this power here is actually what feeds this guy here. So it's a pretty cool little kit. It is, but yeah, I think there's a lot of wasted space here, honestly, myself. I think it could have been manufactured a little bit differently to, you know. Ooh, and there's some kind of oxidation or mold present on the aluminum heatsink here. Cool. So yeah, there you go. I just did your planet. This is a planet. Hpoe 1200G, 802.3AT, 12-port gigabit Hpoe manage injector hub. Okay? That's all she wrote. And, oh, what's this? Yep, there's the power. And once again, I would love to thank all of our Patreons, because without you guys, it would be extremely difficult to produce these videos, that's for sure. And in addition to that, yes, Yuya will also put all of your names at the end of the video, everybody who's contributing to the Patreon. Thank you so much, and don't forget to like and subscribe, and thanks again for NWIC for providing this cool planet switch for us to do a teardown on, okay? Thanks, guys. Have a good night. I think I said everything I'm being told that I'm supposed to say by my awesome editor. All right? Love you guys. Good night.